In this demonstration, I would like to introduce the functions, Python-based functions available to solve the um, ordinary differential equations. So I have opened the website of scipy, which is scipy.org, and I would like to get to the documentation part. So which is a very nice thing, documentation. Okay. And I usually prefer to visit API, scipy API, which is the application processing interface. So over here you have a great wealth of library, a great resource of libraries for scientific functions, like the differentiation, fast Fourier transform, the integrate, interpolate. In the interpolate sub-library, you have functions for the model fitting in multivariable problem, and also the supply interpolation functions. You have the optimization functions available here, signal processing functions here. There is one and the image processing functions, linear algebra functions. So you can learn and make it operational and workable for your problems of numerical orientation. So let's access the ODE solvers. So scipy integrate. The top of the page begins with the integration functions. So I hope my students are familiar with the things as we have discussed them in the earlier lectures, like the Newton course integration. Then there is the quad, double quad integrations. These are essentially the uh, Gaussian quadrature type integration schemes. So for solving an initial value problem uh, of single variable, or if you have a system of solver, the system of differential equation, you can use any of these solvers. So you have the famous solver, the RK23, RK45. Then these are the special ones. Some of them are for solving the stiff differential equations. Then this is the one L soda, which was very famous, and it is still very famous. I'm going to use this, the most generic one, which comes with the method specification as well. So the structure is here. I'm going to use it directly. So it comes with the first argument as function, then the time span, why not, the method selection, and time for evaluation. So you can choose the essential. So you should provide the essential arguments, and then it will work for you. So let's see whether it will work for our problem. So I copy this structure, and I will try to consistently provide it for my problem. My problem is to solve this differential equation y prime equals y minus t squared plus 1, where the initial condition y of 0 is 0.5. This is the RK4 method description. So in my program, I have imported the library, NumPy, and matplotlib. I have a function definition, which is the derivative function. And then the initial condition has been specified. The time limits A0 to A0 at the end of the interval is 5. T span has been defined, and H has been defined. Okay, so let's write the structure. Okay. So the structure says that you have to provide function T span, time span, y of 0, and all like that. Okay. So in my problem, I defined earlier the t-span. AB has been defined. Okay, y of 0 has to be provided. Then method RK45, which is a combination of RK fourth order and fifth order. And it is an adaptive method for calculation. So it automatically look for the optimum step size. However, I'm going to use the one which is like the RK4 method. So I write that solution of the problem. Oh no, I have to have the proper library imported. So import scipy dot uh, where it is. It is in scipy.integrate. So I pick up only the relevant part, scipy.integrate. Like from matplotlib library, we have imported the pyplot functions. So scipy.integrate as ODE solver, right? So the solver is there. Now I can access that code. So I generate y solution is equal to ODE. From the library, pick up the function solve IVP, and function is f. Tspan was defined as tspan, right? And this should be provided as a list function. Then y of 0, this should be an array, right? If you read through that solver description, so let's do it for the time being. So function, the right-hand side of the system, tspan, it's a two-member sequence, interval of integration, right? And y of 0, it should be array-like. And then the method selection. So you have a variety of methods. Then t evaluation, array like the time at which to store the computed solution, right? Okay. So t span should be provided as a list variable. So let's see whether I provided that correctly or not. Yes, t span. This should be provided as a list variable, right? It should have two members. However, the y of 0 initial condition should be provided as array. So I write as numpy array. That is to make it consistent with the Python solver structure, right? This is an array, a vector which only contains one element. Okay, and the time vector, which is the t evaluation for the solver. So it is like this. I think we are ready to see the functioning of this one. So tspan, y of 0, it has rightfully been defined as array. Then I have to have a method description. So it should not be a selection like hit on the basis of hit and try. You should be able to learn the characteristics of differential equations from their expressions and from the sensitivity of step size. Okay, RK45 and the T evaluation. T evaluation is equal to T vector, right? And that's it. T span. T span. T span A to B. Okay, I think the variable description was not consistent. Yes, that is the error. So we are very close to see the working of this one. Yes, it has worked. But now let's see the solution. How to plot the thing. And so I just directly write this one, why solve what has been stored in all that. So this is going to be an object. Okay, so there is message, right? So there is a t vector, right? There is a y vector, right? So how to access those solutions? It's very interesting. I write y solution dot t. So that is the way to get to the time vector, right? The next is going to be very interesting. Okay. Y solution dot y. But if you see the y closely here, so it seems to be written as a matrix because you have the double uh, brackets on the left side. So you have to look for the proper array. So the first array is going to be y0. So I write here y0 and all elements of that. Let's see, is it fine or some more explicit is required? So this is y of 0. So if you have a system of two differential equations, so one of the vector will be stored as in y of 0, the other will be stored in y of 1. That is going to be a complete array.